Good afternoon, all. Today I'm going to talk about smart systems, lighting, and how standards and benefits are driving us here, and how this will become integrated together. I would like to start by talking about maybe the ideal experience that users get when they buy a consumer device. In our markets, we're seldom driven by consumer devices, but yet there have been so many imaging devices out there that it's beginning to jade our customer market. So if the customers go out and they buy a high-end security camera, for example, they get used to, they can sit on their PC remotely, they can drive the camera. If it's a high enough end one, they have manual focus and zoom, and they can turn the lighting on at many stages and adjust the intensity. And they get used to this, and I say expensive for a security camera, but for several $100s today, they can go out and have this kind of experience, and they have many cameras on the network. This, of course, is not our industry, and these are not the kind of devices we will use for imaging, but that kind of experience the users are becoming to expect. Yet when we go off in today's machine vision systems, what do we have? We have industrial cameras, which are higher performance, aimed at imaging, no funny pictures like we get from the consumer devices, true Nyquist limited imaging here. We put C-mount lenses on those, in most cases anyway, and the lenses tend to be fixed iris and focus. They may be adjustable, but they are manual. And then we have LED lighting, bar lights and ring lights and so forth to get the right lighting environment, but also this tends to be their own kind of devices and DC type of control. Very little integration with these parts today, even though the consumers go out and spend much more money to get the performance imaging parts. It leaves them short of what we consider that ideal experience, each one of these having their own interface, if any interface at all. In the cases of lenses, if they happen to be motorized in a machine vision environment, then most likely they're a DC drive today getting a motor, and there's probably a card in the PC or the host environment to drive this. And if you want to know where the lens is at, then we must bring position sensing back to that card. And the card itself has a closed loop system there. And we have yet another device inside the PC to control part of the system, but it's not necessarily integrated into the systems. And if we describe the security camera as the ideal experience, then our machine vision users who are building these high-end imaging systems are left far short of this. And then they get all this manual stuff and they can create high-performance images, but the experience is not what they expected. So these things are starting to change. In the case of smart vision lights, we released earlier this year Bluetooth-enabled smart lighting. So the smart lighting will be a piece in this and start to help us out. And with the smart lighting, you get everything. We can network multiple devices. We can have control those devices. And we, in fact, can have device information and runtime statistics, things that we want for the Internet of Things or Industry 4.0 type factories. In the case of networking, the lights show up on this Bluetooth environment. Each light will show up as a device. You can select the device among many. We have 3 here, but there could be many, many more on the network. And the beauty in this is lighting has always been fairly simple, but once we have this smart lighting environment, and the user has either the application here on the phone or a SDK to use on their PC, then they have much more access and control. So as a manufacturer, we start taking advantage of that. So smart lighting is not only going to give us the connectivity we talk about today, but we're going to get advanced features and functions that allow the user to do more with the lighting than before. If we simply wanted to control things from a fixed pinout and DC the way it was, then having things like multi-zone lighting is difficult. Yet when we have the smart lighting, it's very easy on the application. In this case, the bar light is divided into 3 zones. These style bar lights, as you can see from the diagram, actually plug into each other, so I can have up to 6 of these to make longer and get the size I want. But the beauty in the 3 zones here is you can see just the items coming down the conveyor, maybe different heights, they might be shiny. If nothing else, in long bar lights, they tend to be dark on the end and bright in the middles. So the zone control allows the user to balance out the zones for what his target objects are and the width, and balance out the lighting. So this is an additional benefit we get with smart lighting. But more than that, we're starting to see industry 4.0 factories, the call for industrial Internet of Things or Internet of Things out there. And inside the light, then we are able to offer the user much more information. For example, there's device data out there, the model, the serial number, firmware, so they can know exactly what's in that light. The status and the settings, there's analog and trigger controls there. They can control their trigger leveling if they're triggering the light. They can reconfigure the inputs to whichever pins they want. There's reference data, things like the calibration and the factory measured output. And they can even get things like the data sheet for the specific product over there. But more interesting than all of that is the runtime statistics themselves. The light is monitoring how long it has been off, how many, or on rather, and not only on, but whether it's in normal or overdrive mode. You can see the number of triggers it's receiving, if there's been errors. You can see the intensity value, the amount of current that's running there, the max duty cycle and things like that help the user. Or in the Internet of Things, maybe we've got several machines out here that are all the same and cloned, and one has a little bit lower yield rate than the others. They can start looking at, from the smart devices anyway, they can start looking at this kind of data and start to analyze remotely why this machine that should be the same is giving something else. If the light is saying I'm being mistriggered, then you know that there is some kind of synchronization issue. Even if it's generally working, maybe there's a beam sensor or something triggering the system going bad. So today we chose to make this interface Bluetooth, and for us that was driven, like a lot of companies, by a primary customer that saw Bluetooth as more secure than a wide area network, because you must be physically close to the machine to connect. It also allows us the ability to connect through many devices that are close by, tablets and smartphones and things. So this is convenience, and this is where we are at today with those things. But the truth is the physical interface can be anything. Inside the light, there's just a serial connection over the power so that we maintain a low count pinout. But we can, on the physical interface, which we do as a dongle, we can actually make anything on there, USB, Ethernet, or even the standards like CoExpress or CameraLink could be put on these kind of dongles. So once we're at this kind of connectivity and this physical interface can change, then things start to become more interesting, because behind all of the machine vision standards is in fact GenICam for communications. And GenICam is a virtual layer that provides a complete standardized interface for device discovery, command, and control of those devices. Today, these interfaces and standards have been driven mostly by the camera companies that brought these up. They were necessary for the camera control and all the parameters, as well as the bandwidth. But there's no reason that we can't add things like lensing and lighting to the GenICam layer, since this is a self-describing layer and used for the communication and so forth. So the lights could actually get that kind of interface and be automatic, just as they are on a camera. So today this is kind of a block diagram of what's happening in the camera, but the key point here is that there's everything from the software layer, which could be anybody's vision library, in the case of stemmer imaging, common vision blocks. The GenICam layer then describes the device discovery and control of those devices through the physical interface, which can be Ethernet, USB, CameraLink HS, CoExpress, and down to the camera itself, the physical device. But the point here of this slide is that the layers for getting to a GenICam camera are standardized all the way from the physical connection at the device all the way up to the software library. By contrast, if we look at the lens and lighting, then for the lighting, we've showed you that we have smart lighting available. Other manufacturers will use an external controller but still have Ethernet control of that lighting. But at the moment, there's very, very little standardization of that. And what this means is usually any lighting control that is available on the interface becomes a third-party plug into the software. Most of the software libraries do support this, but we as manufacturers are putting some kind of script out there. You as the users are having to integrate that third-party script into your library and into your host program ultimately to control the machine. And this is, in the 21st century, for lack of a better word, maybe clunky. And the same is even more true for the lens. Very few lenses have control. As I said, if they do, they're probably an analog DC lens with some kind of position feedback. And this is probably a third-party card that's in your PC or other processing device. And they also then wind up being treated as third-party plugins. But this has started to change. So if we go back to the ideal vision of, hey, I want all these things to be remotely controlled over the network and work together as one integrated device, even though that they're individual system components, then the best way in the machine vision environment to do this is over the GenICam layer. And what you're starting to see is there were some commands introduced in late 2017 for GenICam for lighting. Smart Vision Lights did some of that, as well as CCS did it, and that effort was led by Gardasoft Vision down here on the floor, who makes external controllers for us all. That work is a good basis. We do believe that work needs expanded to fill in this vision as I'm painting for you, but the basics for lighting are there, and we need to expand it. The biggest problem with GenICam for lighting is it's defined as optional, so the libraries do not mandatorily have to support it, nor some of the advanced functionality I'm describing here yet created in the standard. But correspondingly then, earlier this year, a group out of Japan of the optics manufacturers, as most of our optics are coming out of Asia nowadays, a group out of Japan calling themselves the Advanced Optics Group actually approached the AIA and the standards committees and said that they wanted to start participating as a group, and they wanted to start creating this kind of GenICam functionality, just as has been done for lighting and other things. So do understand that it's very early, but there's actually a start of this in optics. And in the optics world, you know, we have things like the P-iris lenses, which are mostly for security, but a P-iris lens is actually a digital lens with a little brain in there and stepper motors to control the iris and work smartly in security cameras. This, again, is not what we need for machine vision, but the point is those manufacturers, this advanced optic groups, already have the technology to put the little brain in the lens and put stepper motors on the axes and manually control them in a way that would be interesting for machine vision. And ultimately, what everyone's saying here is that we want to operate on this GenICam layer and be all discovered the same. Your software should pull it up and you should see the list of any attached cameras, and right alongside that, lensing and lighting. And if you select the camera lighting system, it should come up just like the camera with all the parameters you can control, and you should be able to drive it in that similar and constant way. Once we have it on GenICam, then as I was alluding to earlier, then all those physical layers are, all the software functionality is available then on any of these functional layers, because all these standards through the AIA or EMVA and GIA are supported by GenICam as the link between the host software. So GenICam itself is virtual and has no physical interface, but all the things you would recognize as a physical interface for cameras and for vision, in fact, are running GenICam behind them. So when you look at this, then what you can see is our future is smart. Once we have this integrated control, we have that ideal experience. The user can drive their individual high-performance components as if it were one integrated device in that high-end security camera I started with. But by the nature of GenICam, we can go one step farther because GenICam is self-describing, so it doesn't necessarily know what the features are. Things like the camera, the lighting and the lenses, they have a feature, they report to the GenICam layer, I have this feature, the feature is named by a simple ASCII string, it is register driven, it says that feature is controlled over here at this register address, and this register is an 8-bit register with values from 0 to 255, for example. But by the nature of that self-description, then it makes it the ideal layer to wrap a wrapper around it and go to the industrial Internet of Things and the virtual cloud. Because part of the challenge of getting to the Internet of Things and the cloud is what kind of data do I have and how I package it. And when you look at Industry 4.0, it in fact is a standard of standards. It's saying if I have this data, this is how I package it and present it. So in the vision world, we would like to see them all standardized on GenICam. Then we're not writing our own wrappers or trying to plug into there. GenICam makes it very easy to translate this, write one wrapper, and report ourselves up to the higher level factory floor and become part of the industrial Internet of Things. So from our standpoint, the future is smart. This is the way it's going. We will have connected devices, and whether you're going to be PC driven or simply use tablets for maintenance and other things of these, you can expect this kind of integration to occur, and with that kind of integration, you can expect more functionality and user benefits within those devices. Oops. There we go. So that wraps up my presentation for this afternoon. Are there any questions I can answer?